In today's lesson, we're going to take all these skills we've been learning about how to solve systems, and we're going to apply them now. We're going to look at some real life scenarios where we could use this. Here's something you're all familiar with: going out to a fast food restaurant, in this case to eat some tacos. Let's look at this word problem we have. Julie orders 6 tacos and 7 burritos at Taco Barn. That's a lot of food. Her order cost $7.20. Super cheap. I hope this is good food. It's super cheap. Find the cost of 1 taco and 1 burrito. Now let's go ahead and set this problem up algebraically. We're going to go ahead and say that X is going to represent the cost of a single taco and Y is going to represent the cost of a single burrito. We can now take Julie's order and write it like this. 6x plus 7y equals $7.20. Really just 6 tacos plus 7 burritos is $7.20. Now think about what you know. I kind of want to ask the question, is this going to be enough information for us to find out the cost of 1 taco and 1 burrito? And the answer is that no, it is not. So when you just have a single order of food here, and it creates this single line, that's not enough information to get a single answer. Here, you'll know that along a line, when you have an x variable and a y variable, there's actually infinitely many solutions, different combinations. Okay, you could see here, the taco could be 25 cents and the burrito 95 cents, and that would work. Or you could have a 50-cent taco and a 70-cent burrito. That would work. You could have a 75-cent taco and a 45-cent burrito. That would work. You could have a $1 taco and a 20-cent burrito. That would work. And so you have all these different combinations that could possibly work. We do not have enough information to solve this problem. What we're going to need a second order to look at. Well, if we flip to screen 2, that's exactly what we have. Now we still have Julie's original order, but then we add in this new person, Roger. Roger orders 5 tacos and 2 burritos, also at Taco Barn. His order costs $3.70. Well, you see, now that we have 2 lines, now we're in business. And let's write out this system. First, I have Julie's order, 6 tacos and 7 burritos, $7.20. Now I have this new second order from Roger, 5 tacos plus 2 burritos equals $3.70. And think of this graphically now. Now that I have these 2 different orders, okay, here you can see all the hundreds of different combinations that Julie's order could equal. But now if we also throw in Roger's order and all the combinations that that order could equal, well, this point where they cross right here, that's going to be my correct answer. That's going to be the answer. I know that's what it's going to be the cost of 1 taco and 1 burrito. Now we're going to solve it by hand here. So both of these lines are in standard form. This is called a 2x2 system. Both lines are in standard form, so we're going to use the elimination method. And you could choose to eliminate the tacos x, or you could choose to eliminate the burritos y. I think I'm going to eliminate tacos. I know the least common multiple of 6 tacos and 5 tacos would be 30 tacos. So I'm going to multiply everything in Julie's order by 5. That'd be 30 tacos plus 35 burritos equals $36. I'm going to multiply everything in Roger's order by 6. And actually, I'm going to go ahead and make that a -6. The reason why, I know that will make -30 tacos, and that will allow my tacos to cancel out. I'll have -30 tacos minus 12 burritos equals, get the calculator out here, that equals -2220. And now I can add these 2 orders together, and this makes sense. We allowed the tacos to cancel each other out. We multiplied Julie's order by a certain number and Roger's order by a certain number, and it allowed the tacos to cancel out. Now you can see that we're left here with 23 burritos would cost a total of $13.80. Well, look, we've eliminated tacos. We've taken that variable out of the problem. This is easy now. 23 burritos for $13.80. That means each burrito is going to cost exactly 60 cents. A cheap burrito there. And see, now that we know that the burritos are 60 cents, it should be pretty easy to go back and find tacos. I'm going to actually use Roger's order because it's smaller. But with Roger's order, 5 tacos and 2 burritos cost $3.70. But if I know the burritos were 60 cents a piece, then of course I can figure out the tacos. Basically, I have 5 tacos plus $1.20 is equal to $3.70. So using my math skills, that means the 5 tacos combined were all $2.50. And if 5 tacos cost $2.50, then every 1 taco cost only 50 cents. So this is my answer. Tacos 50 cents, burritos 60 cents. A word problem like this, I like to call this a cost per item problem. And a cost per item system problem like this can be solved using the elimination method. You're going to see this on today's assignment on questions 1 and 2. All right, let's go to our next question then. So our next question, Central Cable charges $50 per month plus a $90 installation fee to provide basic cable service. Delta Cable charges $62 per month for basic cable service with no installation fee. After how many months does Central Cable become the better deal? Well, let's kind of set our variables here. So in this case, we want to know how many months, does it take for these deals to kind of intersect, and what is the total cost of that deal going to be? We're going to call these our X and our Y. So look at Central Cable. So this is a slope problem if I've ever seen one. A slope and y-intercept problem. Every month, Central Cable charges $50. Well, that's going to be a slope. And there's also a $90 installation fee that you need to start off. Well, here, the charge is going to start at $90. That's called our y-intercept. That's the starting charge. You have to pay $90 before you can even start. And then every month, that charge will go up $50 a month. Now, let's compare that to Delta Cable. Delta Cable, the slope is $62 per month with no installation fee. So this actually has a y-intercept of 0. You don't have to pay anything at the very beginning, but then every month that you keep this cable service, it goes up by $62. A little key, so a problem like this, I call these types of competing slope problems. You have this charge, this monthly charge of $50, and it's competing against this monthly charge of $62. Anytime you see this, like $50 per month, and that word per is key, that's a giveaway that you're talking about a slope, okay? So we have the slope of 50 competing with this slope of 62. We know eventually the slope of 62 will end up costing more in the long run, but look, this Central Cable has a head start though. It starts with a $90 installation fee. In essence, that gives it a head start. Let's look at this one on a graph. So here in red is Central Cable, and you can see that it starts at $90. You have to pay $90 right off the bat, and then every month it goes up by $50. Okay, you can see how every month the total cost goes up by another $50. That's called its slope. Now let's throw in Delta Cable here in blue. Delta Cable starts much lower because it's free right off the bat. There's no installation charge. But then every month it goes up by $65. And since this blue line Delta Cable has the higher slope, you know eventually it's going to catch up and eventually it's going to cost more. Now that point would be right where these two lines intersect. We're going to find this by hand. Now with this system, both of our equations are in the y equals slope-intercept form. So this is going to be best solved using the substitution method. I'm going to put parentheses around my 65x plus 0, and I'm going to draw an arrow to the y up above it. And in essence, I'm going to rewrite that very first equation, but in place of the y, I'm going to take out the y, and I'm going to replace it with the 65x plus 0. Now at this point, I just have a simple linear equation to solve. I can subtract 50x from both sides of the equation. That will leave me with 15x. I can subtract this 0 from both sides of the equation. That won't change anything. That will leave me with 90. Divide both sides by 15, and x is equal to 6. After 6 months, these cable services, the cost is going to be identical. Whether you went with Central Cable or Delta Cable, the cost will be identical after 6 months. Now you want to know how much that total charge is after 6 months? We can take this 6 months and plug it into either of the equations. I'm going to plug it into the second equation to make it easy. I think that's an easier equation. 65 times 6 plus 0 is equal to $390. So after 6 months, it does not matter. If you use Central Cable, you'll pay a grand total of $390. Okay, but also if you use Delta Cable, you'll also pay $390. This is the point where it does not matter which cable company you use. Now in the long term, we would know that the red line here, the Central Cable, would be cheaper in the long run. Delta Cable, if you're only going to have your cable for less than 6 months, Delta Cable would be the better deal. Okay, again, this type of problem, this is called a competing slope problem. And you are going to see this type of problem on your assignment on questions 3, 4, and 5. All right, so at this time, hop onto Canvas, Canvas quizzes, get these assignments done, and let us know if you need any help. Take care. Bye.